Hello, welcome to our second lesson. Today we're going to go over if-else statements. So our first problem, we're going to check if an integer is even or odd, and check if it's divisible by 5. For our second problem, we're taking from the 2011 CCC, J1, which is called Which Alien? And for problem 3, we're going to create a program that finds the maximum range of a triangle's third edge, where the side lengths are all integers. So if-else statements are crucial when you're coding because you can't do much without them. So to do an if-else statement, you first need if and else, and a condition for if. So if, and then do this if the condition is true, or else, do this if the condition is false. So the condition is normally if a number is equal to a number, if it's less than a number, if it's greater to a number, etc. But there are also other cases. So to see it in the flowchart, we can test if a number is greater than 5. So let's say our number is 6. Since 6 will be the input, and since 6 is greater than 5, the output will be that 6 is greater than 5. Same thing if we test for, let's say, 1. 1 will be the input, and since 1 is not greater than 5, the computer will output it. So this is just a simplistic diagram of what an if-else statement basically is. So this is the if section, and then this is the else. There are also some logical operators that we're going to use, or that you'll probably encounter in the future. So first are these double and signs. Are they called ampersands? I don't know. But basically, so both conditions have to be true in order for the final condition to be true. So in this example, it tests for if 5 is less than 4. Since 5 is not less than 4, we can write that down as false. This is our first, so this is our second. In our second condition, 5 is greater than 3, which is true. But since 1 and 2 aren't true, then it'll be false. If 1 was true, let's say it's 4 is less than 5, now it'll be true. So, since both conditions are true, it'll be true. If any condition is false with AND, then the computer will output false. Let's go over logical ORs. So these are the double straight lines. You can normally see them above the Enter key, I believe. And so this, you only need one statement to be true in order for the computer to read the conditions as true. So for this example, using the same condition 1 and condition 2, 4 is not greater than 5, but 5 is greater than 3. And since it's OR, then we consider it as true. If there were, let's say, 2 false, then it'll be false. If there were 2 trues, then it'll be true. The major difference between them is that for the operators with 2 AND signs, both of them need to be true in order for the computer to read the condition in total as true. For ORs, or the double straight lines, only one of the conditions needs to be true in order for the computer to read the entire thing as true. And lastly, we have logical nots, which are indicated by this exclamation mark. And this needs to be in front of the condition, which basically states the opposite of what the condition within the brackets are. So in this example, 5 is not less than 2, so that would be false. However, since it takes the opposite of false is true, so the result will be true. Same thing if we consider if 5 was greater than 2, we would know that this is true, at least this part within the brackets is true, but the opposite of true is false, so the computer will read this as false. And before we get started, I just need to say one quick thing, that the double equal signs is not the same as a singular equal signs, because the double equal signs are used for booleans to test if two values are the same, and the singular equal sign is used to replace the value of a variable. So I'll demonstrate that before we get into our problems. So since I want to prove that the double equal signs, they're not the same as the singular equal signs, again we can use the exclamation mark equals to say not equals, but let's say does not equal. So this is what we're testing to prove. So let's get an integer, any integer, and assign it to a variable called num. Now we want to see if the computer recognizes if num is the same value as 6. And if it is, then it should print out true, and if it's not, then it should print out false. So let's test it. False. Now let's test if the number, see what happens if we print out num. We should get 5 because we didn't change anything to this. But if instead we do number is now equal to 6, system.out.println, we can just simply test to see if the num now equals 6 by printing it out. And we should get 6, as we do. Now I'll continue with our first problem. So our first problem is to check if an integer is even or odd, and we also want to check if it's divisible by 5. So since we want to use a user input this time instead of a random number, we can simply do this by importing a special package. In order to include this package, we simply do import space java.util.asterisk semicolon. The asterisk just tells the compiler to include everything from the package, and util is the package itself. So from the util package, we want the scanner, and we also want to create the scanner in order for the user to input a number or any value. So in order to create a scanner, we can do scanner, and then the scanner name, which I'll just call it sc, and then equals new scanner system.in. So this is just something you need to memorize. You can customize the name to whatever you like. You can do like in sc or sc. As long as you don't call it scanner, it should be fine, because in order for the computer to get a number, or in this case an integer from the user, we can create a new variable with int num equals, and just do the scanner name dot next int brackets semicolon. You can also use the scanner to find the next line, or the next double, or the next character, whatever. The scanner can be used for all of the integer values, or all of the variables, sorry. Now in order to check if an integer is even or odd, so I'll just make a comment. We can find out an integer is even if when we divide by 2, the remainder is 0. If you can recall from last lesson, in order to find the remainder, we can use modulus. So if, and then our condition. So in our condition, we want to find if the remainder of the number when divided by 2 is 0, then the number is even. So we can just do num plus, and then tell the user that the number is even. If not, then it has to be odd. So we can do else, the open and close curly brackets. So we always need the curly brackets in order to tell the compiler what to do if something is true, if something is false. Just tell them can just tell the user that the num is an odd number. In order to make our code even better, we can also tell the user what to do so they're not completely lost. Please input an integer. Now if we run the program and input an integer, let's just do an odd one first. So we know that this number is an odd number. Let's test it with an even number. And then the compiler will know that's an even number. So an integer is divisible by 5, or it's multiple by 5, only when the remainder is equal to 0. So we can actually have multiple if statements, if-else statements within one program. So if we do if the remainder of the number divided by 5 is 0, then we can do system.out.println, and then num is divisible by 5. Else, we can also do else in a separate line if you don't like it in one line. Else, open and close brackets. We can just tell the user that it's not divisible by 5. So let's run the program. Input an integer. Let's do a number not divisible by 5 first. So we know that this number is an even number, but it's also not divisible by 5. Now let's test with a random number that is divisible by 5. We know that this number is an odd number, and it's also divisible by 5. So this is a very simple way of how to wrap your brain around if and else statements.
So, quick note, I actually got the question wrong during my main recording, and in the recording I assumed that at least meant at least 3 excluding 3, but I found out later that it actually means inclusive, so 3 does count for at least 3. This is on me for not getting the exact problem description right. Serves as a reminder that you should figure out what the problem exactly is asking for before starting, or mistakes like this could happen. And that's just to tell you that, spoiler alert, this is the correct final solution. And what I had in my program is technically not fully correct. I'm still leaving it as it is because it is more, I think that it's actually more helpful to have both an exclusive and an inclusive case. You'll see when you finish watching that. That's all. Alright, so the next problem that we are going to do is from a CCC Junior 1 problem. In this problem, we are given 3 sets of requirements. We are told that TroyMartian aliens have at least 3 antennae and at most 4 eyes. VladSaturnian aliens have at most 6 antennae and at least 2 eyes, and GraemeMercurian aliens have at most 2 antennae and at most 3 eyes. We have to write a program where we are given the amount of antennae and the amount of eyes, and we have to figure out which aliens these might be. So we are given 2 things, and we have to see if they fulfill both requirements, that if they both have the right amount of antennae and the right amount of eyes for them to be considered one of these aliens. And we're told that if it does work for that alien, then we write down that, then we print out the alien, and if there are more than one that corresponds, then we just write down both names, and if there are none, then we just don't write anything. Given that, you should be able to identify that this is a very classic if-else problem, so we are definitely going to need to use if-else statements. So starting off, let us import scanners, which will allow us to take in the user info. If at this stage it is okay if you're not entirely sure how it works, but it is necessary. In fact, you could just copy this code from anywhere and it makes sense at this point. So I'm gonna call my scanner lowercase here. You can change the name to whatever you want. And next what we need to do is we need to define 2 variables, right? So we will be given the amount of antennae as an integer. That means I probably want my the variable that stores the amount of antennae we're given as an integer. So I'm going to say int antennae is equal to, and then I'll do scanner.next int to get the next integer that the user inputs, and then int eyes, again, same case, we'll be given the amount of eyes as an integer, so I probably want to store the amount of eyes as an integer, which is equal to scanner.nextInt. And then we need to think about how we are going to do this. So when in doubt, just start writing code and then figure it out as you go along. So there's going to be some sort of requirement, and if it fulfills that requirement, what we want to do is that we want the machine to print out that. So let's say we start with TroyMartian, since that's our first one. So we want some requirement to happen, and if that requirement happens, we want this machine to print out TroyMartian, the name of the alien species. Okay, so now if we look at what our condition has to be, we know that TroyMartian aliens have to have at least 3 antennae. That means if they have 3 antennae, that doesn't work. They have to have at least 3 antennae. So I'm going to go with antennae larger than 3. That's how you would transfer that statement mathematically. So to convince ourselves, we could try a few cases to show that. So if there are 2 antennae that is smaller than 3, that does not work. That fulfills our statement. If it is equal to 3, that does not work. That fulfills what we want. If it is 4, that's larger than 3, that's what we want. Next, you see that we have 2 statements, and there's the word and. Both have to match for TroyMartians to be counted. This means that we probably want to use the operator and. Recall that the operator and means that both this statement and this statement here have to work for the entire if statement to be true. If either are false, then the entire statement is false, and this is not going to happen. Whatever's in the brackets will not happen, and we want it to happen only if both there are at least 3 antennae and at most 4 eyes. So we are going to say that the antennae is at least larger than 3, and then we say at most 4 eyes. So let's do eyes is smaller than 4. But then we have to think through it. Does this actually work? And if there are 3 eyes, then yes, 3 is smaller than 4, and TroyMartians are going to work. If there are 5 eyes, then 5 is not smaller than 4. This is not going to print it out, and that fulfills our requirement. Always the hardest one, the one that always messes up with your thinking, is what if it is equal? And you always need to figure out if this edge case is going to work or not work. And in this case, if there are 4 eyes, our statement says that 4 is not smaller than 4, so this is not going to print out. But in English, we know that if there are at most 4 eyes, then 4 should be able to count. So we want to change this into a lesser or equal sign. And don't worry if you make this mistake. You can usually just catch it when you're testing. It's always worth testing the edge cases because every now and then you're going to let something like that slip. So next we look at VladSaturnian. Now it is worth thinking, do we want an else statement between our 2 ifs? And it might be just a habit to do else because a lot of the time else is correct, but now we have to think. So we know that they said that if there are 2 potential aliens that work, we need to print out both. However, an else statement means that if the alien is TroyMartian, then it cannot be VladSaturnian. It's going to skip the case if TroyMartian is true. And conversely, if an alien is VladSaturnian, that means it would have already skipped TroyMartian. That's what an else statement would do, which is not what we want. So we know that because we can print out both results and both TroyMartian and VladSaturnian can both be correct, we do not want an else statement. Again, this is those type of edge cases, so it is always worth checking that out, testing it once you're done to see if your code works for that. So then we can sort of use this as a template already. VladSaturnian aliens have at most 6 antennae. We're not getting tricked by this now. We know that this means antennae is smaller or equal to 6. And again, at least 2 eyes, so that means eyes is larger than 2, strictly larger. 2 does not count. And then I'm going to do system.out.println VladSaturnian. Lastly, we do the same thing with GraemeMercurian. If they have antennae at most 2, which means it can be smaller or equal to 2, and at most 3 eyes, so eyes is smaller or equal to 3. The keyword here is the at most. Notice that you could save on a key press if you wanted to change smaller or equal to 2 to smaller than 3. Absolutely, you could do that. It is up to you. I prefer smaller or equal to 2 because it's more readable. Like you see, oh, requirement at most 2, you see 2, you expect to see 2 in the requirement. Again, up to you, but readability always helps. Not that it's actually going to have a difference in the code. So next we are going to finish with that. This way our code should be complete. You can now convince yourself if this is right or not, or you can test it, and to test it I'm going to run this over here. Let's see, for a normal situation we would want something that easily fulfills one requirement. Let's say at least 3 antennae has 4, and at most 4 eyes it has 3. Let's see, okay, it says TroyMartian and VladSaturnian. At least 3 antennae, 4, yes. At most 4 eyes, it has 3, yes. At most 6 antennae has 4, yes. At least 2 eyes, it has 3, yes. Good, we know that works. Now let's try one that doesn't fulfill any of these. We know that if I had 8 and 6, that would not fulfill either. Let's check. Okay, it fulfills none of them. Now let's check one that uses an edge case, right? 2 and 3. So VladSaturnian, at most 6, yes. At least 3, yes. At least 2, yes. But also at most 2, including the 2, yes. At most 3, including the 3, yes. So we can see that that works. If I flip that to 3 and 2, no results. Good, because at most 6 antennae it would have fit VladSaturnian, and at least 2 eyes should not have fit. Again, we want to test all the edge cases, the at least, the at most, the no solutions, the several solutions, and the base case, which is 1 solution as well, which we could do by testing 4 and 5. Alright, so I am convinced that this code should be able to work. Yeah.
We just need to look at something called the first triangle inequality theorem. So this theorem states that the length of any 2 sides of a triangle must add up to more than the length of the third side. And so I've drawn this here. So you can see that A plus B, if we imagine A and B added together, is going to be more than C. Well, let's go to A and B. So definitely we can visualize that if you add these 2 side lengths together, that is much more than C. And you'll find that that's true for every single combination. Now, you can also think about it in this way. Let's say I have 1 side length, and from this 1 side length, I'm going to build up a triangle. So, let's say I have 2 sides. This is maybe 1 side, and then this is another side. Well, obviously from here, I can't lift this one a little bit without making the green side longer, right? If I'm going from flat to lifted, and this is going to have some sort of angle here, I obviously need to make these ones longer. I need to extend them. So that goes back to this rule. If we add up this side, let's say this side A and this side B, then that is going to be equal to more than this side. If we were to compose this line of 2 separate line segments, to make a triangle that connect, we have to extend both of them. So that's why A plus B is greater than C. So to solve this problem, what you're going to do is you're just going to add up the numbers that they give you. So if you're given 8 and 10, you'll just say 8 plus 10 is equal to 18, and then you're going to subtract 1 from this, which is 17. And you're going to subtract 1, since we said that if we're given 2 side lengths like A and B, so if A is 8 and B is 10, A plus 10 is 18, that is going to actually be greater than C. So in order to just have it equal to the greatest value of C, we have to subtract 1, since this equality tells us that 18 is going to be greater than the last side length, not the maximum edge. So the maximum edge it can be is if you were to subtract 1 from that, and so 18 minus 1 is 17, and then that'll be C. look at how we would code that. So here I've just gotten my class ready. We're going to ask for 2 integers, both of the side lengths, and then print out maximum length of the third. So system.println, the maximum length of the third side length, exactly the calculation that we talked about before. And then you can see that it works by 10 and 18. Let's try another one. So let's try, 5 and 7. How about that? And so 7 plus 5 is 12. 12 minus 1 is 11. So that checks out to me. Notice how I can also enter in my numbers like this. So if I say 5 and just put it on the same line as that 7, and I'll still get that. And that's because these are both still integers, but now separated by space. As long as they're separated by either space, or 5 spaces, or an enter, then you're good to go, and then the program will recognize these as separate integers. So yeah, it's kind of cool.